Exam for review, reviewing all that probability good stuff. First question says that an experiment involves rolling a standard die. This experiment was performed 100 times and the results are shown in the following table. The question is asking us what is the experimental probability of rolling a 6. So I want to know, well, what's the chance of me rolling a 6? Right? So when I look at the table, I'm paying attention to how many times I rolled that 6, which is 18. So I rolled the 6 18 times out of the 100 times I did my experiment. Now notice how this says reduce your fraction, which means I should simplify it. I can divide top and bottom by 2 to give me 9 over 50. So experimental probability of me rolling a 6 would be 9 over 50. Next question says, what is the theoretical probability of flipping a coin and it landing on tails? Well, when you flip a coin, it can either land on heads or tails, right? So you have two total possibilities for when you pick a coin. And if I want to know what's the probability of it landing on tails, there's only one tails on a coin. So I would have a 1/2 chance of flipping a coin and it landing on tails. Next question says that a friendly contest involves drawing a marble from a bag that contains 7 purple marbles, 14 pink marbles, and 13 yellow marbles. If a purple marble is drawn, Mark will win. If a pink marble is drawn, Randy will win. And if a yellow marble is drawn, Willow will win. We want to know who is most likely to win this contest. Well, if I look here, 14 is the highest amount of marbles, okay? And 14 is pink, and it looks like if a pink marble is drawn, then Randy wins. So that means that Randy is most likely to win this contest because he has the most marbles in that bag. Kelly has a craft box full of buttons. It has 8 yellow, 12 black, 3 red, 2 pink, 10 green, and 5 brown buttons. If she randomly chooses a button out of the box, one at a time, and then returns it, choose the statement below that is true. So A says that Kelly has an equal chance of pulling any color marble. Well, this can't be true because she has a different amount of every color marble, right? She has 8 yellow, she has 12 black, 3 red, 2 pink, 10 green, and 5 brown. So A cannot be true because she has different numbers of all the different colors. B says that Kelly will more likely pick a brown button than a red button. So let's look here. If she has 5 brown buttons and she has 3 red buttons, it says that she's more likely to pick a brown button. Well, she does have more brown buttons, so that would be true because she does have more brown buttons here. Which events are impossible? So impossible means that it could never happen ever, ever, ever. There's no way that that could ever happen. So the first option says rolling a number that is less than 3 on a standard dice. Well, that could happen because I could roll a 1 or a 2. B says drawing a red card from a standard deck. Again, that could happen because half of the cards that I have in a deck are red. C says rolling a number that is greater than 7. Well, that is never going to happen, right? Because numbers on a dice are 1 through 6, so I could never roll like an 8 or a 10 because those are too big. D says drawing a green card from a standard deck. Well, if I think about the colors in my deck, I could pick red or black. Those are not green, so drawing a green card is also impossible from a standard deck of cards. Next question says a bag contains 3 purple marbles, 12 blue marbles, and 4 yellow marbles. Which option best describes the likelihood of drawing a blue marble from the bag? Okay, so I have 12 blue marbles. Now, to figure out the probability of me picking a blue marble, I first need to figure out how many total marbles I have in this bag. And to do that, I'm just going to add up all my different colors. So I have 3 purple plus 12 blue plus 4 yellow. So 3 plus 12 is 15. 15 plus 4 is 19. So I have 19 total marbles, and I want to pay attention to drawing a blue one. And there are 12 blue. So I would have a 12 out of 19 chance of picking a blue marble. Now that's definitely more than a 50-50, right? So it's more than even, but it's not 100% either, which means that it is likely that I will pick a blue marble, also because there's 12 blue marbles and then there's 7 of all the other colors. So you don't necessarily have to find the probability. You can just kind of think about this question. There's way more blue marbles in this bag than any of the other colors combined, which means that the chance of me picking that blue marble is going to be pretty likely since there's so many of them. Alright, next question says that a bag contains 5 red marbles, 10 green, and 12 blue. A marble is randomly selected and then replaced back in the bag. Then a second marble is randomly drawn. So we're picking 2 marbles from this bag. We want to know which answer correctly describes how to find the probability of selecting a green marble and then a red marble. Now with this question here, this is where knowing the difference between and or in your probability comes into handy. Since I have this word and in between my 2 probabilities, right? I'm picking a green and then I'm picking a red. And tells me that I need to multiply. Anytime you see the word and in probability, that means you are going to multiply. So all these 3 down here that say add, we're not going to even look at those because I know that I need to multiply my probabilities. Then the next thing we need to do is double check that we're multiplying the right probabilities for the right colors. The question here is asking me for a green marble and a red marble, which means I want to pick the answer choice where I'm multiplying the probabilities of my green marble and my red marble so that it matches my question. A card is drawn from a deck of 52 cards and a typical dice is rolled. Which answer correctly describes the probability of drawing a card that is a queen and rolling a 3? Here we have that word and again. So I am drawing a card that's a queen and rolling a 3. Hopefully you remember from that last slide that and means we're multiplying. So I'm going to multiply the probabilities of drawing a queen and rolling a 3. A marble is randomly selected from a bag that contains 4 green, 10 orange, and 4 red marbles. The marble is replaced and then another marble is randomly selected. What is the probability of selecting a green marble and then an orange? So here I'm actually solving for my probability. Now I know it has the word and in the middle, which means I'm going to be multiplying my probabilities. And the 2 probabilities I need to figure out is what's the probability of me picking a green marble and what is the probability of me picking an orange marble. Well, to first do this, I need to figure out how many total marbles I have in my bag. So the total will always go on bottom. So I have 4 green, 10 orange, and 4 red. So 4 plus 4 plus 10 is going to be 18. So 18 is going to be the denominator in both of these. Then I have 4 green marbles. So 4 will go on top. And 10 orange marbles. 10 will go on top here. So since I am multiplying these probabilities, when you are multiplying with fractions, you multiply straight across the top and straight across the bottom. So 4 times 10, it's going to be 40. 18 times 18. Let's see what that would be. So this is 64. 8 plus 6 is 14. So this is 324. Now, one thing that you could also do here is you could plug this into a calculator. So let me show you what that would look like if you were to do that. Remember that using a calculator on problems like these is actually pretty wise, especially because you can use this to kind of help you double check your answers to make sure that you're not missing anything. So if I type in that 4 over 18, and I am multiplying it by 10 over 18. and then I convert this to a fraction, it will tell me that the final answer for my probability is going to be 10 over 81. And notice how it simplified it for us. So if I had typed in that 40 over 324, I should get the same exact simplified fraction. So the probability of me picking a green marble first and then an orange marble second would be 10 over 81. And I apologize, I did something weird with my answer choices for this problem. So the correct answer isn't listed here, but this is the correct probability, and this is how you would solve a problem similar to this on your exam. Alright, next question says that Rosa is rolling a 6-sided dice. Rosa rolls the dice twice. We want to know, what is the probability that Rosa gets the same number twice in a row? So this is tricky because you have to think. She's rolling the dice 2 times. Okay, so think about a dice and any number you could roll on it. Let's say a 4. I want to know what's the probability I roll a 4 and then I roll it again because I'm rolling the same number twice in a row. So what I'm actually doing here is rolling a 4 and rolling a 4 again. Okay, which means that we are multiplying our probabilities because it has that word "and" in the middle. And if you think, rolling a 4 on a dice is a 1 out of 6 chance. When I multiply straight across the top, straight across the bottom, I get 1 over 36. So this question is tricky. Don't be fooled. It is not 1 over 6. Okay, that's just what's the probability of rolling any number on a dice. Here, I want to roll the same number twice in a row. Okay, so it's 1 over 36. You could also think about it like it's typically hard to roll the same number 2 times in a row, and 1 over 6, that's a pretty high chance of that happening. But 1 over 36 is a lot smaller. So since it's a lot harder to get 2 numbers twice in a row, your probability should be much smaller, which means that your fraction should be something like 1 over 36, or something where if you were to convert it to a decimal, it'd be relatively small. Which answer correctly describes the probability of the following compound event? We are flipping a coin that lands on heads or tails. So flipping a coin that lands on heads or tails. Well, if I flip a coin, it's either going to land on heads or it's going to land on tails. Okay, now notice how this is, it's a compound event, right, which means we're doing 2 things. And this question uses the word "or" in the middle. Okay, so I am adding my probabilities here, probability of heads and probability of tails. Whoops, yes. So if I were to think, well, if I'm rolling a dice here, I would have 2 options, right? I could land on heads or tails. So I would want to have 2 in my denominator for both of these. And the different outcomes I could roll heads or I could roll a tails. So one of those options would be heads and one of those options would be tails. Now again, since it has that word "or" in the middle and it's not "and," this means that we can add them together. So if I were to add these together, whoops, you add your numerators, so 1 plus 1 is 2, and keep your denominator the same. This equals 1. So since that equals 1, that means that it is certain that this is going to happen, because if I flip my coin and it lands on heads or tails, I'm flipping it twice because it's a compound event, those are the only 2 options that I could ever land on, which means that it's 100% certain that this is going to happen. We want to know which answer correctly describes the probability of the following compound event: drawing a black card and flipping a coin that lands on tails. Again, be careful with this one. This answer is not even. Okay, it is not even. We are drawing a black card from a deck and flipping a coin and it landing on tails. So probability of drawing a black card and probability of flipping a coin and it landing on tails. So drawing a black card's a 50-50 chance because there's only 2 colors, red or black. And it means that we're multiplying, and the probability of flipping a coin and it landing on tails is 1/2. So when I multiply these together, I should get 1/4, which actually means that this event is unlikely. Okay, so be careful with these, because yes, both of these probabilities on its own would be 50-50 or 1/2 or even, but remember, you have to keep in mind that you were doing a compound event, so you need both of these things to happen, which makes it much harder to accomplish. Two friends at a restaurant each order a flavored lemonade. The flavors are blueberry, strawberry, and raspberry. Use the format friend 1, friend 2 to create a sample space that correctly represents the friend's lemonade choices. Well, say friend 1 is super set on ordering blueberry. Okay. If friend 1 wants blueberry, friend 2 could also get blueberry, or friend 2 could get strawberry, or friend 2 could get raspberry. Right? Say friend 1 is like, nope, I am getting raspberry and I don't care, you will never change my mind. Well, friend 2 could also want raspberry, or friend 2 could want blueberry, or friend 2 could want strawberry. Are you seeing a pattern? Say friend 1 says, strawberry is my all-time favorite flavor and I will always get strawberry when I have the choice. Well, friend 2 could be like, same, I want strawberry. Or they could be like, nah, I want raspberry. Or they could say, no, I kind of feel like blueberry. So those are all of the different ways that those two friends could order a flavored lemonade. A section on an English test has 2 multiple choice questions, each with 4 options, A, B, C, and D. We want to know which table shows the possibilities for a student's correct response for the 2 questions using the format first answer, second answer. For this question here, you really are just paying attention to the table. Okay, this table over here, the very far one, this table is not correct, because if you notice, everything in this first row is AA, 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 AA. That's not right, because this B and this A means that this one here should be AB. This C and this A means this one here should be AC, and so on. So you are just looking at the tables and identifying which one is correct and which one is wrong. Hopefully you'll be able to notice that this one over here is the right table we want to pick, because when I look at all of the different pairs, they're all different and they all match. An experiment involves rolling a dice and flipping a coin. The following table shows the possible outcomes of using the format die, coin. How many outcomes include an odd number and a head? Okay, well, here are all my heads, right? So odd numbers would be 1, would be 3, and it would be 5. So 3 outcomes include an odd number and heads. Alright, a math test has 4 true or false questions. The following list shows all of the possibilities for a student's responses to those questions. If a student randomly guesses all 4 questions, what is the probability they get all 4 questions incorrect? Okay, so let's see. We want to know what's the probability that they get all 4 questions incorrect. And from looking at what this is telling me, it looks like I can either pick all true, true, false, and so on. So knowing what's the probability they get all 4 questions incorrect, well, if they get all 4 questions incorrect, that would mean that they'd have to miss every single one, right? And if they missed every single question, that would be a really small probability. There's 16 total options here, right? If I were to go through and count them all, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. 16 is going to be my denominator, and to get all 4 of them incorrect, that would only be a 1 out of 16 chance, which would be probably something like this, where we have all 4 false. That's very unlikely. All right, next question says that a person has a coin and a standard deck of cards, and a 6-sided dice. How many different outcomes are possible for picking up a card flipping a coin, and rolling a number cube. So this question, these are kind of fun. What you have to think about is, well, how many total outcomes do I have for each event? And then you just multiply them together. So if I'm flipping a coin, if I'm flipping a coin has two outcomes, right? I could land on heads or tails, so that's 2. If I'm looking at a standard deck of cards, a standard deck of cards has 52 total. And a 6-sided dice, well, that has 6 different outcomes. So all we need to do is multiply all of those together. And again, don't be afraid to use your calculator to help you out here. If I have 2 times 52 times 6, 624, which means that I would have 624 total possible outcomes. A restaurant has a build-your-own personal pizza on their express lunch menu, and a customer can choose only one from each category. The table shows the different choices. How many different ways can a person order a lunch pizza? So again, this is kind of asking how many different outcomes are there? Well, if I look at my crust, right, I have 3 different options for my crust: thin, thick, or deep dish. If I look at my cheese, I have 3 different options for my cheese: mozzarella, provolone, or Italian. And if I look at my toppings, I have 3. I can pick pepperoni, mushroom, or sausage. And again, to figure out how many different ways, all we need to do is multiply them together. So 3 times 3 times 3 gives me 27. Fred's parents took him to a video store and told him he could get 1 snack food and 1 movie. The movies and snacks he can choose from are listed. Which of the following tree diagrams correctly shows all of Fred's choices of combinations? Well, if he wants to get licorice, he can watch any of those 3 movies, right? And if he wants to get popcorn, again, he can watch any of those 3 movies. And if he wants to get sour sticks, he can watch any of those 3 movies. So that second tree diagram is the one that we would want to pick. An experiment consists of randomly drawing a card from a standard deck, recording its suit, and then flipping it twice. The unfinished tree diagram that represents the following is an unfinished tree diagram that represents part of the experiment. So what we need to do is figure out which one of these answer choices will correctly finish this tree diagram. It says in our description that the coin is being flipped twice. So I need to have some sort of coin flips on this coin number 2. So when I look at coin number 1, I need to have a heads or tails attached to each one of those options, which means I should have a heads and a tails, and I should have a heads and a tails, and I should have a heads and a tails, and a heads and a tails, and so on. Okay, so each item in coin 1 column needs to have not 1 branch but 2 branches. I have 2 branches on each one of these. So each item in coin 1 needs to have 2 branches, a heads or tails, in the coin 2 column. An experiment consists of randomly drawing a card from a standard deck, recording its suit, and then flipping a coin twice. Create a tree diagram for the experiment and use it to answer the following questions. What options are possible outcomes for this experiment? Now, I don't necessarily need to create a tree diagram here because I kind of can visualize what's happening. I'm picking a card first, then I'm flipping a coin, and then I am flipping a coin again. So all I really need to do is go through these answer choices and determine which ones have a card suit, a coin, meaning heads or tails, and another coin, heads or tails. So I have card suit, coin, coin. Card suit, coin, coin. Not card suit, tails is not a card suit. Card suit, coin, diamond is not a coin. And then heart, head, tail. Card suit, coin, coin. Carla tosses 3 coins, and based on the tree diagram, what's the probability that Carla will toss 1 head and 2 tails? So this tree diagram is kind of tricky to look at. Instead of labeling it H or T, it actually uses pictures. So this is heads, right? Up here would be heads, this is tails. And on this very last column here, it tells you the number of heads that we have in each of the branches. So if I want her to toss 1 head, well, here's 1 head, 1 head, and 1 head. So she gets 1 head 3 times out of 8 total, right? If I were to go down this very last branch and count how many total coins I have here, I would have 1, 2, 3, 4, 5, 6, 7, 8. So that is where I get that 8 in the bottom. So 3 over 8 would be my final answer here. An experiment consists of randomly drawing a card from a standard deck, recording its suit, and then flipping a coin twice. Create a tree diagram for the experiment. Use it to answer the following question. What is the probability of drawing a spade or flipping a tail? So I'm not going to go through how to solve this because the answer on this exam does not match what the question is, and they will not be changing it until this course comes out again next semester. So for this answer, just type in 5 over 8. That is not the correct probability for this problem, but again, they have the wrong answer for the different question. So the question and the answer don't match. So it should be 5 over 8. So just go ahead and type that in. All right. In 2014, half of the men in America shaved daily, and a group of researchers wanted to know the probability that 3 out of 5 men shaved today. They created a simulation with a coin flip to model the situation. They used heads to represent that a man shaved today and tails to represent that a man did not shave. They flipped a coin 5 times and recorded the number of heads and tails in the table below. According to the 10 trials in the simulation, what is the probability that 2 out of 5 men shaved today? This should say 3. What's the probability that 3 out of 5 men shaved today? Okay. Well, heads represents that they shaved, correct? Which means that since I want to know 3 out of 5, I am looking for anything that has 3 heads. And the order of the 3 heads does not matter. I am just looking for how many times do 3 heads pop up. So here I see 4, nope. Here I see 2, nope. 2, nope. 4, nope. 3, this one works. 2, 2, 3, none, and 3 again. So 3 times out of 10 do 3 out of 5 men shave that day. So for these questions, read it carefully, read what the question is asking you to find, and then go back and just identify what you're looking for. So Jimmy and his brother each have an equal probability of randomly to be selected to do dishes. And Jason wants to simulate the probability that more than 4 evenings, this Jason should say Jimmy. Whoops. Typo. My fault. I have too many J names in my brain. Jimmy and his brother each have an equal probability of randomly being selected to wash his dishes after dinner. Jimmy wants to simulate the probability that more than 4 evenings will go by without him having to wash dishes after dinner. He decides to conduct the simulation by flipping a quarter, with heads representing an evening where he washes dishes after dinner and tails representing an evening where he does not wash dishes after dinner. He keeps flipping until he flips heads and records the number of flips that was needed. For example, if 2 flips were needed to get heads, that indicates he washes dishes on the second evening. He repeats this 50 times and records the data in the table below. Based on the simulation, what is the probability that more than 4 evenings will go by without Jimmy having to wash dishes after dinner? Okay. So what we're looking for here, so 50 is our denominator, correct? And that's because he did this experiment 50 times. So we need to figure out how many evenings or how many times he got lucky and did not have to do dishes after 4 evenings in a row. Well, if he has to go 4 evenings without doing dishes, that means on the 5th night he will do dishes. So if he gets heads 5 or more times, that 5th time, meaning he'll have to do dishes then. So if I look at those numbers that I have squared off there. That's a 2, 0, 0, and a 1. So if I add all of those together, 2 plus 0 plus 0 plus 1 is 3, which means he has a 3 out of 50 chance. Now the question here wants me to enter my answer as a percent. So if I take 3 over 50 and multiply it by 2, I get 6 over 100, and 6 over 100 would give me 6%, which means that Jimmy would only have a 6% chance of going more than 4 evenings without having to do dishes after dinner. Next question here says that a school cafeteria serves sandwiches with different combinations of bread and deli meat. Bread choices include white and wheat bread. Deli meat choices include turkey, ham, and roast beef. The cafeteria has the same number of each sandwich combination. Brian wants to determine what is the probability of randomly selecting a turkey on wheat sandwich or a ham on wheat sandwich. He uses a simulation where flipping a coin represents the bread choice and rolling a number represents the deli meat. It says here that if he flips a heads, that will represent wheat bread. Tails will represent white bread. Rolling a 1 or 2 will represent turkey, and rolling a 3 or 4 will represent ham. And this trial was conducted 24 times. We want to know what is the probability that he will get a turkey on wheat or a ham on wheat sandwich. Now, because it uses the word or, that means that it doesn't matter. It doesn't have to have both. It can't have turkey and ham. It just needs to have one or the other. Thankfully, both of our sandwiches here are on wheat. So since they are both on wheat, that means I am looking for heads, because heads represents wheat. And turkey is represented by 1 or 2. And ham is represented by 3 or 4. So I am looking for any time in this table where I have heads and I'm landing on a 1, 2, or 3, or 4 on my dice. So here is one. Let's see, I'm just going down. Here's another, and another. 1, 2, 3 in a row. Another one, and another one here. So let's count how many times that happened. 1, 2, 3, 4, 5, 6, 7, 8, 9. So it happened 9 times out of the 24 total that he did. So 9 over 24. Ruby plays on a soccer team. In general, she makes 1 out of every 2 goals that she takes. Which simulation best models the probability of Ruby making a shot? So 1 out of every 2 is a 50-50, which means I am looking for a 50-50 chance. Okay, so if I let multiples of 2, that would be on a dice, that would be 2, 4, and 6, and all other numbers, which is 1, 3, and 5, that is a 50-50 chance, because I have 3 to 3, which is the same on each side. Next question says that 2 different community volunteer groups each include 20 men and 20 women. Which simulation could be used to determine the probability of randomly selecting 2 people? So here I am selecting 2 people, which means I need to do 2 things. So this bottom one where I'm flipping a coin once, that's not going to cut it. Now again, with the 20 men and 20 women, that is a 50-50 chance. So I'm looking for any of these answer choices where I have a 50-50 chance. Like here, where I'm letting a red card and a black card represent women and men, that is a 50-50 chance. Alright, that is all I have for this exam 4 review. If you have any other questions or would like another attempt, please let me know. Have a wonderful rest of your day.